This is lesson 21C1. This first slide is the review of the derivative function. So this represents a derivative. dy dx gives the rate of change in y with respect to x. If the y increases, the x increases, then the derivative value will be positive. If the y decreases and the x increases, then the derivative value will be a negative. So here's some examples of rates of change. One is temperature varies continuously. The height of a tree increases as it grows. The prices of stocks and shares vary each day, depending on the day of trading. Suppose S sub t models the distance traveled by a runner. Then the derivative function is the instantaneous speed of the runner. You might say that the units are meters per second, or our notation for meters per second is m, which is meters, and then that per, and then s sub negative 1, so that represents meters per second. All right, here are some more examples of rates of change. So you have an h of t models the height of the above ground of a person riding on a Ferris wheel. Then the derivative function is the instantaneous rate of the ascent of the person in the Ferris wheel. So you might say that units are meters per second. Next example, the function c of t models the capacity of a person's lungs in which the changes in the breathing occur. The derivative function might model then the person's instantaneous rate of change in their lung capacity. So their unit of measure might be liters per second. So here's our example. The volume of air in a hot air balloon after t minutes is given by this function. So here is our volume function, and our unit of measure is meters cubed, and this is our domain from 0 to 8 minutes. So part A is find the initial volume of air in the balloon. So what we're asking you to do is to evaluate the function for time of 0. So we say the volume at time of 0, we're going to replace the t with 0. Orders of operation, simplify it, and we get 2. So what does that mean? The volume is 2 meters cubed when the time equals 0 minutes. Part B, find the volume when the time is 8 minutes. So we would do the same thing. We would evaluate the function at 8. So substitute 8 in for t. Simplify using our orders of operation. So I'll go through this one. So you go 8 cubed, which is 512, multiply 2 times 512, 1024. Go on to the next term. 3, 8 squared is 64. 3 times negative 64 is negative 900, or 100 minus 192. Continue on. 10 times 8 is 80. Add 2. Bring down the 80 and the 2. Combine terms. and we get 914. So what does that mean? That the volume is 914 meters cubed when the time is 8 minutes. Part C. Find the derivative function. So we're going to use our power rule. So we're going to bring down that 3, subtract our power. Bring down the 2, subtract our power. And then drop our t. Simplify it. So this is our derivative function. Now find the rate. So rate is working with your derivative function. What is the rate of increase when the time is 4 minutes? So now we're going to evaluate the derivative function at 4 minutes, and that'll tell us the rate. So replace the 4 with t in the derivative function. We simplify it. Combine like terms, and we get 82. What did we find? We found the rate of increase in that hot air balloon at 4 minutes. So what is that rate? Meters cubed per minute. So 82 meters cubed per minute is increasing. And then we're done. Sorry.